Going on to topic 7.3, we're going to multiply radical expressions. Now the vocabulary for this are basically terms you've already covered, so we'll skip that part and let's get right into it. Now if the index number is the same, then the rule is you just multiply the radicands. So this will be the square root of 110. And there is no perfect square, so we can't simplify that. Again, if the index numbers are the same, we just multiply the radicands. So the fifth root of 15x cubed. Now notice when you multiply these radicands, they are conjugates. You remember that from earlier sections. So this will be the square root of c squared minus d squared. And if you factored that, you would get this, and you can't simplify that anymore. Now in example 8, as you look at it, we see something here is sort of interesting. A minus 3. Well, if you factor this, this will factor into a minus 3, the quantity squared. So here, in a sense, you have one of them. Now you have two of them. When you multiply this together, it's going to be the fifth root of a minus 3 to the third power. Now, if for some chance we ever got to the fifth power there, then we could take the fifth root of that and it would just be a minus 3. But it's not there yet. For number 9, again, the same index number. So we just put it under a common radical sign. X, U, Y, V. Now for number 10, what they're looking for, again, same index number, is just to multiply that. So that'll be 3 times x is 3x. 3 times a negative 5 is a negative 15. 7 times x, 7x. 7 times 2, 14. Okay, some of the simple rules. The key is it must have the same index number if you're going to do it this way. All right, that earlier part was not too bad. And now we're going into something different. They're asking us to take radical expressions and simplify them. So here I want to stress the strategy, and again, your teacher may tell you a little different technique, and that's fine, but here is a strategy that might be useful. So you want to see what were the factors of 200 such that you may have separated them into perfect squares. And you say, well, what are the factors of 200? Well, 2 times 100. 100 is a perfect square. So what I like to say is under the first radical sign, then you put that perfect square of what you took out of there as a factor. And then the other. And then what do you have? Well, the square root of 100 is 10, and the square root of 2. Now, by the way, whenever you come into the square root of 200, it's always going to be simplified as 10 the square root of 2, and this is how it's done. Now, are there other ways to get there? Yes, but again, we don't want to confuse you. We'll work with one strategy. Again, we want to divide this into, and again, you do some of this mentally. Is there a perfect square factor of 63? Yeah, 9 times 7. So, the square root of 9 is 3, the square root of 7. Again, we're going for strategy. Now in number 13, again, a strategy might be put 2 sets of radical signs with the proper index number, and you're looking for factors of 27 that might be a perfect cube. 27 is a perfect cube. So we put the 27 under that radical sign. Now how about factors of x to the 6th that are a perfect cube? Well, how can you tell? Well, you just divide 6 by 3, and that's a perfect cube right there. X to the 6th. Now, when you get to y to the 2nd, there's no factor of y to the 2nd. That's a perfect cube. So that goes into your other radical sign. So now you take the cube root of this, which is 3. Cube root of 27 is 3. We're going to divide the x to the 6th by 3. This gives us x to the 2nd. And then the third root of y squared. So again, the strategy is, what perfect cubes can you pull out of this? Put them here. Whatever's left over, you put there. Take the cube root of it, and then write your radical. Now, I was out of order a little bit when I forgot to put number 14 up. So let's do 14. So we know it's going to be a negative. But again, the cube root of something, the cube root of something. Now, as we look at 24, is there a perfect cube factor in 24? Yes, 8. What's left over? A 3. That goes in the other parenthesis, other radical sign. Now, x to the 12th. Is that evenly divisible by 3? Yes, so that's a perfect cube. So this then will become a negative. Cube root of 8 is 2. Cube root of x to the 12th, remember we're just going to divide it by 3, is x to the 4th, and then what's left over, the third root of 3. Okay, I hope it's not too cluttered for you, but it saves me having to pause and rewrite. Now for 15 and 16, they're looking for functions, and these are function notation. But again, they're asking you to simplify. And our technique is, again, putting 2 sets of parentheses, radical signs, excuse me. Thinking of something else here. Now, as we look at the number 40, is there a perfect cube factor of 40? Yes, 8. And what's left? A 5. Remember, 8 times 5 is 40. Now, is there a perfect cube factor in x to the 5th? Yes, x to the 3rd. What's left over? X to the 2nd. So this will become, I'll write it over here, 2x, the cube root of 5, x squared. Again, we're looking for strategy. The strategy is put two radical signs under the first, all those that are perfect, whatever index number you're dealing with, and whatever's left over in the other. Take the third root of this and just write the other. Number 16 is a little tricky. So let's do that. In fact, I'll change colors. Now, the first thing, I don't know if you can see it here, but there is a common factor here of 3. So I'm going to take that out. This will be the square root of 3. Now what's left under the radical sign is x squared minus 4x plus 4. I think you'll all agree to that. Now, I don't know if you recognize this, but this is a perfect square trinomial back from chapter 5, which will then factor, and we have to write this all again, the square root of 3 times the square root of x minus 2, the quantity squared. Are you following that so far? Now, notice there's a 2 here, which we don't write. If we take away the radical sign, we're left now with x plus 2, the square root of 3. That is this times this. We're taking the square root of something that's squared, it just becomes the radicand. Well, I don't want to do that. Now, keep in mind that we could put absolute values around that to really make it super correct, because that could have possibly have been a negative somewhere in there that made it what it is. Okay, so 11 through 16. All right, going on. Again, it's nice to have an easy one from time to time. Did I copy that one down correctly? Let's see here. That's number 17. Yes. Well, okay. Again, that same strategy. Under one radical sign, another. Is there a perfect square factor of x to the 5th? Yes. X to the 4th. Anything even. And one left over there. And then this is y to the 10th. That's even, so that's perfect. So now we take the square root of this, just divide it by 2, x to the 2nd, y to the 5th, the square root of x. And then here, the same, third root. Third root. This is a perfect third. Now, b to the 6th, so we have a b left over there. And this is going to be c to the 12th. And we have c squared left over. So now we're looking of multiples of 3, our index number. So then this will become a to the 2nd, b to the 3rd, no, that's b to the 2nd, excuse me. Thinking of something else. Now this one's going to be c to the 4th. Again, we're just dividing it by 3. It gives us a 2, a 4, And then what's left over? BC squared. The tedious part of this is, putting all this into MATLAB. All right, number 19, fifth root. So, fifth root. You're developing a pattern of what you're going to do. Now, can you see a perfect fifth power here? Well, 2 to the fifth is 32. So if I factor out a negative 32 there, that's a perfect fifth. And what's left is 10. And then C to the fifth, and what's left over is C to the third. And we have D to the 15th, and what's left over is D to the second. So we're looking for multiples of 5. So here there's only 1 in there, and then 3 left over. Here we have 3 times 5 is 15, so that's where we get the 2 left over. And again, being an odd index number, we can have a negative under that. So this is going to be a negative 2C, D to the third, as 5 goes into there once, 5 goes into there 3 times. And then we just have this afterwards. So I could write it again, but I think you can see it. All right, for number 20, using our basic technique, we want to divide this into those that are perfect factors of 4, or powers of 4. So if we divide that by 2, we get a 16, and 2 to the fourth is 16, and we have a 2 left over. Now there is no x, if that's just the 3 there. Now y to the 20th is a perfect 4th power. And here we're going to get z to the 8th. So we have z to the 3rd left over. So now 4th root of 16 is 2. 20 divided by 4 is y to the 5th. Z to the 2nd, and then we add that to it. Now remember, in this second radical sign, we shouldn't have any more perfect factors that could have been factored out. We'd have to have put those in that first one. Now for number 20, they're changing things around a little bit. They want you to, let's say, multiply and then simplify. But again, I'm going to try to show you a technique that may help. Now, what is 14? Well, that's the square root of 2 times 7. And what is 21? And I can put it all under a common radical sign. That's 7 times 3. I put the 2 7s together because what would this multiply to? Well, 49. And then this is going to be 6. So what is the square root of 49? 7. 7, the square root of 6. And you could have multiplied and then tried to figure it out, but I think this little technique is useful. Here was the one I was thinking that was easy. So this is 5 to the first, this is 5 to the second, becomes 5 to the third, which is 125, which is a perfect cube. So this just becomes 5. The cube root of 125 is 5. Okay, winding this up. Again, they look a little tedious here, but let's see what we can figure out. Now notice our index number is 2, and our radicands are exactly the same. So in a sense, another way to write this would have been this way. And since there's a 2 there, take away the radical sign, put the index number underneath this exponent. 2 over 2 is 1. This just becomes 28x to the 5th. In number 24, it takes a little bit of thinking about it. 4 times 6, that's 24. And there's a couple of ways to do it. Now, factors of 24 are 8 and 3. 8's our perfect cube. And then we're going to have 8 to the 7th. So a perfect cube factor would be a to the 6th with an a left over. So for this one, this is going to be 2a squared when we take the cube root of this, and then the third root of 3a. So again, we're combining a couple of our techniques here. And some of this you may be able to do mentally. So we're looking for perfect cube factors. Again, that same technique. So we would get c to the 5th. So the perfect cube factor out of that would be c to the 3rd with c to the 2nd in our other radical sign. And this would be d to the 11th. So we're going to need d to the 9th, which is our perfect cube factor. And then we have that's d to the 10th. 8 and 2 are 10, all right. The 9 still comes out of the 10. Now you're just left with a d to the 1st. So c to the 5th, we take out a 3 and a 2. D to the 10th, we take out a 9 and a 1. These are our perfect cube factors, which now become c, d to the 3rd, and then the cube root of this. All right, number 26. See if you can see this. So it's going to be the third root of, using our same technique, this to the 4th and this to the 8th will give it this to the 12th. Well, I don't need that other radical sign, because this is going to be t minus 2 to the 12th, which then becomes t minus 2 without the radical sign to the 4th. All right, this next one, as I look at it, this is sort of a big number, but let me work this out, and because this is going to take a little time. Okay, and I focus this in a little bit here. So what I was doing was, again, looking for a strategy just as you would to do it. And the strategy I came up with was, what are the factors of 50? Well, 5 times 5 times 2, that's 50. And 75. 5 times 5 times 3. Well, here I have 1, 2, 3, 4, 4 factors of 5, which is 5 to the 4th, which is a perfect 4th power. What's left? I have a 2 and a 3. I put that over here. Now I have x to the 5th, x to the 2nd, which is x to the 7th. Well, perfect factors out of there would be x to the 4th, x to the 3rd. And then I have y to the 3rd, y to the 1st, which is y to the 4th. So again, as you're sitting at your paper and you're working this, it's a little easier sometimes to try to do it as if, you could just put it all together. You have to think about it. So, when I take this now, the 4th root of 5 to the 4th is 5. X to the 4th is x. Y to the 4th is y. And then I'm left with the 4th root of 6x to the 3rd. And that's my answer. And I'm sticking to it. And I did a little bit of thinking for number 28 as well. 5th root, 5th root. Now I have r to the 2nd, r to the 9th. That is r to the 11th. But I'm looking for a perfect 5th root of that, which is r to the 10th. So 2 plus 9 is 11. I'm going to take r to the 10th out of it. I'm left with an r. And then here, s plus t to the 4th, s plus t to the 6th, make it s plus t to the 10th. Okay, now we have perfect fifths in this, under this radical sign. So our answer will then be r to the 2nd times s plus t to the 2nd, and then the 5th root of r, sort of right out of room. And again, multiplying radical expressions. We wish you good luck and encourage you to, do the practice in quiz bees.